All right, everyone, welcome to this week's presentation from the DBA Fundamentals Group. This week is Tame Your Unruly Data with Constraints with Mr. Rob Volk doing all of the presentations work. Today is September 5th, 2023. No, it's not September 5th. It is September 12th.
Oh, yeah.
I almost got that right. I was close. September 12th, 2023. In the upper right-hand corner of the screen, you'll see all of the leaders of the DBA Fundamentals Group, Steve Cantrell, Shane O'Neill, and myself, Kevin Wilkie. If for any reason you need to get hold of us, you'll have our Twitter handles on the right-hand side of the screen. Below that, you'll have our multiple social media platforms that we're on, so you can watch every move we make. First off is Meetup, where most of you probably got hold of this information to actually get onto this presentation today. Be sure to look at that for any of our upcoming presentations as we go through, and you'll find all the details about it there. Below that is our wonderful website, dbafund.com, where you can get any of our past and upcoming presentations, all the information you need to know about them as well. Below that is dbafundtube.com, where you can actually see all of our past presentations, all those that have been recorded. Be sure to like and subscribe so you can know the minute that we put out there the latest and greatest of our presentations. Below that is our other social media platforms where you can see what we're talking about. So Twitter, Slack, and LinkedIn. There's always kind of stuff going on there as well. As I said, today's session is being recorded and will be available within 1 to 2 days. It's going to be on dbafundtube.com, so be sure to check us out there. Some upcoming conferences. These are some of my favorites that we have coming up. The first one is later on this week, Data Mosh Pit. It is actually in Germany, so get your medal on at the Data Mosh Pit and make it happen. Later on this month is a summit that I'm actually one of the organizers for, Future Data Driven Summit 2023. It'll be on the 27th of this month, where we have all kinds of stuff on anything with data science, data management, cloud and hybrid architecture, data visualizations and dashboards, and business intelligence. So please be sure to come out and join us virtually for that. If you haven't registered, be sure to register today. Also, Microsoft Ignite is coming up November 15th through the 16th. I have all these websites that shown on the screen, so you can see, learn more, and register for all of them. Also, with that, please remember to turn off your camera and be sure to mute yourself so that we can all focus on Rob as you give a presentation here. And be sure to type any questions you have into the chat window so we can make this as clean, as easy as possible for Rob. And so with that, over to Rob.
All right, thank you, Kevin. I'm gonna share my screen and let me know what you can see.
I see PowerPoint.
All right. That's what I was hoping for. All right, thank you everyone for attending today. And as Kevin already mentioned, my name is Rob Volk. I'm a senior DBA. And this session is Tame Your Unruly Data with Constraints. As you might have imagined, I presented this at Past Summit last year. And if you had subscribed to the videos for that event, you would be able to get a video recording of this. This will be slightly different for purposes of time. It was 75 minutes at Summit, so it'll be a little less than 60 minutes today. I apologize if I cut out any or cut short any demos that I have. If you have any questions about things, or if you would like a copy of the slides and the demos afterwards, you can email me at that email down in the corner there. And with that, I'm going to get right into constraints. Normally, I would ask the audience if they know what a constraint is. I'll just assume that you're raising your hand, that you've heard of them before. And this presentation was based on some experiences that I had at a particular job where the data was in less than ideal condition. And I will show a couple of demos. They are slightly changed from what I presented at PASS, but it was basically to give people an idea of the kinds of things they might see in the wild, such as, for instance, a database named sheet1 star or sheet1 $sign with tables named sheet1 $sign. You've probably seen stuff like this. And it basically means you imported some data from Excel, because that's where a lot of my problems came from. And then you'd have things like duplicate names here. So here's Madonna. Her stuff is out of. Someone asking a question? No, okay. I'll continue. So again, this demo is a little bit different, but I'll cover some of the examples that I had. You might have encountered things like you get zip codes imported from Excel, and the leading zeros were cut off because it gets converted to a number, and the leading zeros are not significant as numbers. They are for zip codes. We had things where we had to do utility billing, where we had to take occupancy and make occupancy a fractional number, so you could have half an occupant. These are not for serial killers living there, but they were reasons for, dividing a bill up. You might have to cut it up into less than a whole person for those kinds of things. We had zip codes that were declared char 25, not just varchar 25. And that led to things where sometimes cities or states or the whole address would be dumped into the zip code column because people weren't paying attention when they entered it, that kind of thing. We also had issues where we didn't always catch certain values that would be outside of the domain, like a $10,000 water bill. I might come back to that later when I have a better example of that. We also had 99 people living in a single room apartment. That was actually a deliberate choice because they had a legacy calculation where they would sometimes offset a certain number of occupants there. So those were the kinds of problems that a constraint would be able to solve, but they were never put in place in that database. In fact, we had to relax certain constraints that were already in the system because we were acquired by a larger company that wanted us for our better billing software and then made us disable the features that made our billing software better than theirs. So those are some of the things that I'll address here with certain demos, and also to talk a little bit about what certain constraints do, why you might want to use them, their purpose, not just in theory, but also in practice, because relational databases actually have a branch of mathematics behind them. And it's not just set theory. There's an additional relational mathematical definitions that were created to talk about why you have some of these constraints and what the problems they're supposed to solve. And again, I usually take a quick survey, but if any of you are not just designing databases or working with databases that other people designed, but have to do what they're now calling data engineering, where you're bringing in data from multiple systems, either ETL, other data orchestrations, whether they're in the cloud or they're on premises and all that, you'll probably run into a situation where certain systems will have better data integrity, cleaner data than other systems. And you might want to look at architecting some of your transfers, I can't remember what they're calling them. Like they used to be called operational data stores, staging areas, things like that. You might want to see if you can apply some constraints in there in those places as well, because it'll help you, instead of having problem data cascade down through all of your systems, you could try to clean it up and fix it at one stage, and then it'll be in better shape as it goes downstream from there. And one other issue, hopefully I'll have time to demonstrate this, is that constraints can actually improve performance. When I started with databases 25 plus years ago, constraints could have enough of an impact where you might not use them for the sake of performance. And with our current systems and all that, that's really no longer the case. And again, with the query optimizer, you might be able to apply constraints to improve performance in certain circumstances. So I'll start with some definitions, and I'm going to abbreviate these a little bit on the assumption that you're probably familiar with most of them already. The first level of constraints that we'll have are domain constraints. And in relational theory, a domain would basically be the column or the type of data that would go into a column that you were adding to a table of some kind. So it might also be known as an attribute. If you're old enough, they would also be known as a field if you work with older database systems. But basically is I want to have a column that stores someone's name. Okay, that's character data because it uses alphabetic characters. I might have someone's date of birth. That would be a data type of date or date time, and it doesn't allow, say, alpha characters. It allows numbers, but those numbers also have to be a specific format, a specific type, because a date is actually a compound data type. It's not just a numeric value like 1 or 2 or 3. There's multiple parts of it. And that would basically be one of your first constraints, is to pick the right data type. When you get into additional aspects of domain constraints, you want to know, is this data required? Does this data have additional things that might limit the values you put into it? But generally, it's just the kinds of things that you apply to individual columns. You then get into entity constraints, and these are the things that identify an entire row. However many columns you might have, if you fill them all out, you'll have a full row. And now you want to have things like, is this entity unique? Am I identifying it in a way that prevents duplication? You know, 2 John Smiths or 2 Jack Smiths or something like that. So I might need to create what's known as a key, some kind of unique constraint that makes sure that I'm not storing either the same person twice, or I'm able to differentiate from, say, 2 John Smiths that are 2 different people, but they have the same name, that kind of thing. And then lastly, the relational data is where you take as minimal amount of data as possible. You have 2 completely different types of entities that you have some kind of relationship to. And you want to minimize the amount of repeated data you have. You basically want to have a key of some kind that identifies a single entity, say, for instance, an account or a customer of some kind. And then you have an invoicing table, and you want to ensure that that invoice goes to a valid customer. And that would be a relational constraint. And those would be accomplished using foreign keys. And most databases support foreign keys. I don't remember if MySQL, the newer version, they have foreign keys, but they didn't enforce them. I think that's true through at least version 5 point something. I don't remember if that was fixed in version 8. But SQL Server has foreign keys. You can enforce them. You can also disable them, that kind of thing. But they allow you to ensure that you don't have a phantom customer with an actual invoice that has money attached to it. You can ensure that it has a valid customer associated with it. As I started mentioning, is that domain constraints, they fall under these 4 particular areas. The first, again, being your data type. Make sure that you pick the right data type for what you're putting in there. So if you have dates of some kind, pick a date data type. If it's a number, pick a numeric data type. Don't use character data for things, especially for dates. I'll have an example later where it'll show you that it's not really a good idea. The next constraint for a domain would be whether that particular domain is required, where you can allow it to have a null, which means no value, or if you're requiring it to be not null, that you have to have a value in it. So this would be someone's name. You can't just have an empty first name and an empty last name. That's not a person. They need a name of some kind. You would have to have some way of identifying them by name, however you'd address them. Hello, Kevin, that kind of thing. Within that requirement of null or not null, you might have an additional check constraint to say, is this a valid value? And the example I would have is for the utility bill, we'd say, hey, the utility bill can't exceed, say, $500. So that would have prevented that problem where we had a $10,000 water bill that got sent to a customer or to a property, and they had to pay it somehow, even though it was basically, there was a leak somewhere. They weren't necessarily responsible, but because we had generated the bill, they had to pay it in order to clear it with the utility company. So if we'd had a check constraint in place when they tried to calculate the bill, that check constraint would have failed, and we would have known, hey, there's something wrong with this amount. And then lastly, in cases where you may not have all of the information you typically collect, let's say you're processing life insurance claims, and there's a date of birth and a date of death. And if someone hasn't died yet, you may not want to put in, you don't want to put in a default value necessarily for the date of death. That's not the example I wanted to use. But you might have a circumstance where you do not want that date to be null, and you would pick a default date that would be symbolic. In other words, it's either so far in the future that it's immaterial, or it's something that you can program your system to recognize as this is someone who has not yet died. And then you would then update their date of death, let's say, with their actual date and time that they passed away. So this is where you could substitute a default value for something where you can't have a null of some kind, or null has some other meaning or some other circumstance where you have to differentiate between data that doesn't actually exist versus just something you didn't know at the time you entered it. And to continue, once you established your domain constraints, you now start to look at entity constraints where, one, you determine uniqueness. You can do that through two kinds. One is a primary key and one's a unique constraint. The main difference being that a primary key has to be defined on a column that's not nullable. So you can't have nulls at all in a primary key constraint. You could have unique constraints that allow a null, but it would only allow a single null. In SQL Server, there's a workaround where you could have multiple nulls and still have unique values that are not null, but their unique constraints only allow for one null. You would have to use that workaround if you wanted to have multiple nulls. And then lastly, a check constraint, but you might want to look at multiple columns rather than just a single column. For instance, there was an interesting data quality issue. I think it was in 2012. The National Health Service in the UK had found something like 3,000 men in the UK in their system who were pregnant. They were diagnosed as pregnant. And that came about because they were using diagnostic codes that were, I think, 4 characters. And if you fat-fingered one of the characters, you'd have some other kind of illness, and then they're suddenly pregnant. So I shouldn't say fat fingering and becoming pregnant. That could be misconstrued. But in any case, that's pretty much what happened. These guys got pregnant accidentally just from a data entry issue. And they also had instances of teenagers being diagnosed with arthritis and some other geriatric diseases because they didn't have constraints on saying, hey, check if someone's male or female, in addition to if they're going to be listed as being pregnant, or say having prostate cancer or being female. That would, in other words, these are diagnoses that are very specific to sex, and they did not have the checks in place to ensure that these couldn't be misdiagnosed. So that's something, and I've seen stuff like that too, where a combination of values may not be valid, and depending on how many there are, you might be able to make a check constraint that can do some simple checks to make sure that these two conditions, where they're I lost my train of thought there, where they're discordant, basically, they can't happen in your system. They would have to be in some kind of agreement where they would be logically incorrect to have these two conditions happen at the same time. And then, as I mentioned earlier, the relational constraints are enforced by foreign keys, and in most systems, particularly in SQL Server, you have a reference table, which is usually called a parent table. And in a customer invoice situation, your customer table would be the parent table. The referencing table, or the child table, would then have a key back to, say, the customer ID. And then for every invoice that you have, you'll have an invoice ID that's unique. You'll then have a foreign key back to the customer table on the customer ID column. And customer ID would also be in the invoice table so that you know this is the customer that's ordering this information. And then if you have an invoice table, you might have a line item table. And then the line item table would have a reference to the invoice ID, which is unique in the invoice table. And then that way you can ensure that these line items are associated to only one invoice, or at least a valid invoice. You'd have to take steps to make sure that the line items don't get duplicated. And as it says here, this is like a background check on your data. Is that you're not just, in the case of AdventureWorks, you're not just selling bicycles to some guy off the street. he's already an established customer. You know where to ship the bicycles to, where to send the invoices, where to send the bills, how to collect payment. He has some payment stuff registered with you. So that's usually the typical example for that kind of constraint, that kind of relationship there. So let's, before I get into that, so any questions from anyone?
No questions.
All right, okay. So let me do this. So I'll do this maybe not quite backwards, but let me go back here. And that's the one query I didn't open. Give me 1 second. Actually, let me come back to this. Let me demo a few things first. Let me just see what the next. Yeah, let me do a few demos of the items I've covered so far. So we talked about having, let me go back to a couple slides here. Data types, null, not null, check and default. Let me go back here. Okay. So let me cover data types first. Apologize for these being out of sequence here again. So I mentioned earlier is using the correct data type for the type of information that you're storing. So I wanted to point out some circumstances or some issues you might see if you were to say use a date string to store dates versus an actual date data type to store a date. So in this case, I'm going to just create two columns here. One is computed, and it's actually going to try to cast the string that I put in as an actual date. And as you can see, I've got a couple of strings here that I've put in. I've got 2022 with dashes, November 16 with spaces, 16 November, and so on. And as you can see, these are all different string values, but for the ones that can be converted to a date, they're all exactly the same date. So the way this is formatted isn't, is just basically decoration at this point. Even though they're different string values, they will convert to the same date type. And then down here, you might sometimes see this either in Excel or Access or something like that, where this will convert to a date correctly because it has, even though it has the day of the week in it. And as you can see in SQL Server, it's not actually functioning correctly. It's trying to cast it to a date and it won't allow it. But it also leads to one particular issue. I'll just mention it because normally I'd point something out. You'll see that there's 2 different days of the week for the same date, November 16th. And that's the kind of, it's basically a data type check that you get when you use the date data type that you don't get when you use a string. Is this doesn't actually care about the day of the week. It will determine the day of the week from the date itself. Whereas if you have strings and stuff like that, you would not be able to, you could have this kind of inconsistent date that would go in there. And I used to have a demo where MySQL used to support February 30th as a valid date, or February 31st, because it wouldn't actually look at the combination of month and day or year. It would only look at, oh, the day part of it is somewhere between 1 and 31, so it's valid. So February 31st would be a valid date in MySQL. That has been corrected a while ago, but for quite a while, they were complaining about it, and it took them quite a while to get that corrected. So we've looked at some date types. I wanted to also show issues with numeric data. This is actually something of the opposite, where you might look at, say, a credit card number, and you might say, or a social security number or a zip code, and you say, well, why don't we just store them as numbers since they only have digits in them? And one of the circumstances I'll show here is we have a zip code here with a leading 0, and that leading 0 disappears. As you can see here, it's only a number 1, 2, 3, 4 instead of 0, 1, 2, 3, 4. Credit cards, even though credit cards only they do not have leading zeros, they're still not numbers. And the advice that I recommend for issues where should I choose a number or should I choose a string is if you look at the data, if you're not going to sum that data up, if you're not going to divide it by anything, you're not going to divide a credit card number by another number. You're not going to subtract them. Same thing with Social Security numbers. They're actually numeric codes. They only use digits, but they're not technically numbers. There are circumstances where there is some math that can be done with them, but they would not be done in the system that you would have. They would only be done by the originating source of the data. In the case of the Social Security number, that would be the IRS. They might do math on it, but you would not. It's an identifier. It's meant to be unique. Same way with a credit card number. These are unique identifiers. They only use numeric digits for their codes, but they are still codes. So you should actually not store them as numbers. You should store them as character data, which I'll do down here. And then what I'll do is insert the same data. And then when I show them as character type and numeric type, as you can see, when they're character data, the zip code is preserved properly. I can also ensure that, in this case, the zip +4 actually needs to have a dash in there. Even if you stored it without the dash, if you're going to actually print it somewhere, you have to include the dash between the first five digits and the last 4 digits. It wouldn't be valid for the post office if the dash was missing. And that wouldn't be something that you could store properly in a numeric value. So you'd have to do that as a character type. All right, I'll close that. I think we went on to null and not null. So one of the issues with null, if you're familiar with relational theory, and there used to be a lot of heavy debate about this a while ago, is because null is not a value, and in databases it's meant to represent an unknown value or a missing value. And the issue is that when you get to cases where nulls show up in your data, there are assumptions you might think where, hey, I'm looking for, let me just create a few here. So I have, again, first name, last name is null, and I have combinations of Rob and Volk where one or the other is null. And I want to basically pick, in this case, I have 2 Robs where first name is equal to Rob and last name is equal to Volk. And as you can see, I get the two Robs in the first one, and I get the 2 Volks in the second one. But now I want to find all of the ones where the first name is not equal to Rob. And now I don't get any matches, even though I know I've got a couple of them that are null. The issue is that it can't tell what it's not equal to, because null is not equal to anything. Null isn't even comparable to another null. For instance, if I don't know someone's last name, if there's 2 people and I don't know their last names, can I assume that their last names are the same because I don't know them? And the answer is no, you can't make that assumption. They're unknown. Both names are unknown. That doesn't mean they're the same. They're not comparable. You can't compare one null to a second null that way. And similarly, where I'm looking for names that are not equal to, first name's not equal to Rob and last name's not equal to Volk, they don't show up because the ones that are not equal to them are null, and I can't compare nulls to anything else. In that case, I would have to use this construct here, where I'm saying the first name is specifically null, or the last name is specifically null, and then that gives me the results that I would be expecting from these first 2 here. And that's one of the reasons why, as best you can, you want to be able to keep your columns not nullable as best as you can, because it cuts down on these circumstances where you have to do this 3-valued logic, where you have to consider if the value is missing, I have to say where first name is not equal to Rob or first name is null, where I basically have to combine these 2 where clauses. It complicates the query, and it also usually causes poor performance, because if you have an index of some kind, you wouldn't be able to use the index if you had that OR condition in place. It would end up scanning the entire table typically. The index wouldn't have nulls in them, or it has to, apologies here. The logic that you're querying for is something that can't be answered by a single value in an index. So you would not be able to seek on an index or do a range scan on an index. is what I meant to say. Any questions about that?
No questions. I think we're okay.
All right, I'll keep going. So we had data types not null, and now I'll show off a check constraint. And this is to help with, again, circumstances where, okay, I've chosen the right data type, but I also want to ensure that I have the right kind of data in there. And what I didn't demonstrate before, I think this one I'll try to put some invalid data in here. So I'm setting up some, in this case, a social security number, and I'm putting a check constraint that says, hey, it has to have 3 digits, it then has to have a dash, it then has to have 2 digits, another dash, and then 4 digits. So it's a total of 9 digits plus 2 dash characters. I'm going to do something with credit card where I'm going to say the credit card has to be nothing but digits. There's no dashes. It can't have spaces or anything else. It can only have digits in there. I have a zip code with 5 digits only, and then a zip plus 4 that has 5 digits, and then a dash, and then 4 digits. And now that that's created, I'm going to insert these values here. And those all succeeded. And then when I select them, you'll see the SSN is formatted correctly, credit card is correct, zip code, zip plus 4, and all that. And in this case now, I'm going to try to insert conflicted with a check constraint numeric code column SSN. So in this case, the SSN is not formatted correctly because it's missing the dashes. So you have the option of enforcing that kind of constraint, but in this case, I'm requiring the dashes, and that check constraint looks for them particularly in that pattern. So this one fails, violating that check constraint on the Social Security. And then lastly, numeric codes, the insert statement failed, and this one's on the zip code column because it's got letters in it. It doesn't have, it's something that's a non-digit character. And this is the kind of simple thing that can save you all kinds of problems when you get data, especially if you're importing it from Excel, because again, it'll lose the leading zeros. You'll have 4-digit numbers. You might even have 3-digit numbers in there. And then if you put this kind of check constraint in there and you import it, you'll get an error right away, and then you can then address that kind of data quality issue. But at least it'll keep bad data out of your system. I think these were the only ones I had for check constraints. I wanted to do some for numbers as well, but as I mentioned earlier, I had cases where utility bills were far outside their normal ranges, and having a constraint to check for values. I think I actually have that in the Discover thing here. I'm going to, I'll do this one too. This is pretty quick. So I set up a table here for first name, last name, middle initial, and I set a default for an empty string here for the middle initial, and date of birth, I set a default for January 1st of the year 1000, the year 1, actually. So as you can see, I don't specify the date of birth for any of the values that I insert here, so they all default to the same value. And in the case of Mickey Mouse, I just use the keyword default to say I want you to put the default value in for his middle initial, and then for Fred Flintstone, I actually put in a literal null because I want that to remain null. I don't want that to default to whatever I have. I wanted to indicate that Fred Flintstone, I do not know his middle initial. I will find out what it is later. So after this insert runs, this select basically gives us back what we expect to get. All the dates of birth are the default value. I gave Elmer his middle initial, Mickey Mouse his default, and so on. What did I want to show? I did want to show a check constraint. Let me put this into AdventureWorks. Okay. So I wanted to point out something with the domain constraints on the check, because it's actually one of those Let me find it here in AdventureWorks. It was actually a nice example of something, and it's not just the character data that I wanted to show. I believe birth date is one of them. So yeah, in AdventureWorks, you'll see that there's an employee table, and the birth date column has a check constraint, and it's actually checking that employees were born after January 1st of 1930. And they were born at least 18 years ago from the current date. And part of this was they hard-coded, I think at the time AdventureWorks was created, this would have made the oldest employee something like 66 years old or 76 years old, I can't remember. So they were saying I couldn't hire anybody. I didn't want to employ octogenarians in my company. I didn't want them to be working until they're 80 or 90 years old or whatever. This person would be 93 years old now. They also don't want to enforce child labor. They don't want to hire anyone who's underage. So they actually have a constraint in here that prevents you from entering a birth date of someone who's too old or too young to work at the company. And this might seem obvious in retrospect, but how many of you have fat fingered a date and you could accidentally enter, someone and all of a sudden they're 160 years old instead of 60 years old or 115 years old. So this actually protects you from out of range values on both sides. Again, too young or too old. Oh, here it is. The hire date, 1966. So they had to have been hired after July 1st, 1996. And that would have been, 66-year difference between when they were born and when they were hired. They also can't be hired. They can't be hired after tomorrow. I don't know why they have that in there, but you added one day to the current date, and their hire date has to be less than that date. This is where a fat finger could be, hey, you fat finger the next month or the next year in, and now this would give you protection against that kind of mistake, because someone could be fat fingered and hey, they're not going to start for a year, even though they're an employee. Their hire date could be a year from now, and they're collecting salary, even though they don't technically work for the company yet. That's what you're protecting against with those kinds of checks. That's what I wanted to demonstrate with that particular example. Any questions?
Well, we do that now. I know you're ready for these. All right. If you want to format a date column returned in a select statement, for example, DDMMYYY, is there a performance impact doing the format in the select statement versus storing it in that format in a varchar to begin with?
The performance is, there is a performance issue with the format function in SQL Server compared to using the convert function. The format function is a .NET function. It's a CLR function. And you might have to search for this, but Aaron Bertrand, I think it's either MS SQL Tips or SQLperformance.com. Might even be on both, but Aaron Bertrand has a good write-up on the format function and its performance implications. The issue with formatting it as a varchar column, I don't know, I guess the example I had wasn't as clear on that. The problem with that is there is no enforcement of the integrity of a date value in varchar. And you really can't enforce date integrity. One of the examples I had was you had either Wednesday or Thursday for November 16th as the day of the week. Even if that's ignored by the database engine, it's not a valid date that it can convert to something. You would then have to do string manipulation to remove the day of the week. However, it's abbreviated. If they spell the day of the week out versus they abbreviate it, the first three letters, there's no way to make sure that you have a valid date if it's stored as a varchar. Don't store it as a varchar. If you store dates as varchar, I will find you and I'll give you a noogie. I'll give you lots of noogies until you change them.
Awesome.
Yeah. Look at me, look at how I turned out. And this is from years of cleaning up things like bad dates, bad addresses, and stuff like that. Do you want to look like me? Do you want to end up like me? Do you want to be doing this presentation 20 years from now? Warning people not to store dates as varchar. Assuming you
So-
don't, stop doing it.
Let's hope not. All right. Also, another question. If we want to avoid null issues, should you set a default value for the field every time? Or is that just a waste of space?
No, you set the default basically once. When the table is created, you would then add a default constraint to the column. You can declare it at the time you create it, you create the table. You can also create a constraint. You would say alter table, add constraint, and then you would say default, and then you would put the word for, F-O-R, and then you would indicate the column that is for that default value. I don't want to do it here by typing in a demo. But you can apply apply a constraint on a column. A default in particular has to have that default for, and then the name of the column that you want to add the default to. You can change the default later. You might have to drop the constraint and then add it back again. But you would only use it in the circumstance where if you don't know what the, like I specify here, you can use this word, this default keyword, in whatever position that you would have a default value for middle initial or whatever column you declare the default for. So in this case, I just said default and it's an empty string. There, let me do X. There, I typed in a demo. You happy now? Okay. So Mickey Mouse now has a default of X as his middle initial, where before it was an empty string. So this would be an instance where you could change the default after. I could say alter table, drop constraint, and then add the default constraint back in. But you know, this would be the only time where you would mention a default. You'd only have one default at a time. If I say default here for Fred, and I run this again, so Fred gets the same default value. That's the only time you do it. I don't remember if you can do this as an insert select where you say select default. I don't remember if it works that way, but it does work in this values clause like you have here. I don't know, does that answer your question? Does that help?
Yeah, I think so.
Okay. All right, let me close that. Okay. Entity constraints. So I'll demonstrate these fairly quickly because we have about a little over 10, 12 minutes left. So uniqueness, this came up a lot pretty much at every job I've had where we had duplicate data. We actually entered the same customer more than once. They got two different account IDs because the account ID was just an identity or some other auto-generated number. So there's instances where you might need to look beyond not just the system-generated primary key that you use. You might want to look at other columns, what would be referred to as a natural key. And now that the actors are on strike, I can have some relevance to this particular example. The Screen Actors Guild actually has a rule that you cannot be credited as the same name as an already existing member of the Screen Actors Guild. So in this case, we have two actors. They were both born Michael Douglas, but one of them is Gordon Gekko, the other one is Batman in Beetlejuice. So Michael Keaton was born Michael Douglas, but when he registered for the Screen Actors Guild, he had to change his name. So he's now Michael Keaton. There's also two different actresses who are Vanessa Williams. One of them is the former Miss America. I can't remember. I think it's this Vanessa Williams, and this is another actress. She's credited as Vanessa L. Williams. So if you might notice that if you go to IMDb, there's instances where they will have actually the same exact name, but they will be they'll have some kind of they'll have a different key ID. They have some alphanumeric code, and then you'll see if they actually have the same exact name, like literally Michael Douglas, there'll be a Michael Douglas and a Michael Douglas with a Roman numeral 2 after it, or something like that. I think for the actors, that may not be the case, at least for members of the Screen Actors Guild. There's other countries that don't follow that rule, so you might see 2 actors with the exact same name in IMDb. But this is their rule, and this is what allows them to ensure that actors get the proper credit, which has follow-on instances for like residuals. A lot of the things that they're striking for is to make sure that actors get the correct recognition. And also with certain scandals going around, that one particular actor who has a drug problem or murdered somebody or something like that, the other actor with the same name doesn't stop getting work because this other actor was a schmuck of some kind and was causing that kind of problem. It ensures that they're not being misidentified, more or less. I don't remember the exact the wording around this regulation and all that. It was just something that came up that I thought was interesting. So in this case, even though I have a social security number and I'm calling that a primary key, I'm making sure that this credit name is unique. So I can't put in, if I try to insert these Michael Douglases again, let me do that one, just comment that out. So if I try to insert him a second time, I can't because he violates the primary key constraint, or I'm sorry, the unique constraint on the credit name, because I'm trying to put in Michael Douglas a second time. All right. You go to entity check. So I went over the uniqueness and all that. Now I want to show a check across multiple columns. And I'll do something simple here. I'm going to check that the date of birth is less than the current time. I don't know when a child is going to be born in the future, unless I know that there's going to be an induced labor. But even then, I won't know the exact moment that the baby's going to be born. I also want to ensure that I'm going to have their dates of birth and their dates of graduation, and they really should graduate high school after they're born. Graduating school before you're born just doesn't sound like it's a valid case. And when I select this, I put in my name here. That's not my actual date of birth. Just for purposes, we'll do that. Now, when I try to put in my actual graduation date, and you'll see that this violates this particular check constraint because my date of birth is after my date of graduation. So this other Rob Volk, this other Rob 2 person, does not get inserted into the table. Oh, and this is the link I was talking about before, and I'm going to copy that and I'll put that into the chat here. Give me a moment so you can all read about it directly. There you go. All right, let's get back to thing here. So yeah, there's some more information about that particular issue with the pregnancy and the other instances here. And I'll put in these 2 others that are really, really good articles about how you can use constraints in really awesome ways. And that includes an ebook that's offered by Redgate. And I believe the PDF is free, and you can also order the paper version as well. But there's at least one chapter in the defensive database programming on how to use constraints and how they're good for defensive database programming. You can, prevent mistakes from happening before they happen. And let me see the relational one here. This one, yeah, I can do this one pretty quickly. What I'm going to do is extend these tables from the Screen Actors Guild and also to movie appearances, and I'll insert the actors that I had before. Good anyway. All right. So we have our actors, and I'm going to insert their movies that they starred in. And what I did was I didn't use their credit names. I actually used their social security numbers. These are obviously not their social security numbers, but they're identifiers that are unique in the system. And then what I can then do is join my movie appearances to my Screen Actors Guild on the social security number. So this guarantees that the correct actor gets the correct payments and so on. And now I can connect Michael Douglas to Basic Instinct and Fatal Attraction and Wall Street, Michael Keaton to Batman and Beetlejuice. Okay. Oh, and these are the two different Vanessa Williams. Okay, so that's the difference there. So this is how you would typically do that, is you have some kind of internal ID that you generate, and then you make a foreign key between the two using this references keyword. I'm saying this movie appearances table references the Screen Actors Guild table, and they do it on this column here, which is the social security number in both tables. I have a similar example here with Netflix and the Netflix queue, but we only have about a little over 7 minutes to go, so I will skip that. And again, if you're interested, let me know via my email or let Kevin know. We can probably get that emailed over to you. That's not the one I want. There we go. So let me go over how you can find documentation. I showed earlier how you can find constraints. And Microsoft has this interesting, sys.objects and sys.types of constraints views here. This SYS schema is the system schema, and this allows me to look for objects that have different types of constraints within the system, because I'm looking for this type description to be like the word constraint. So it's very clear when you look at the objects, I can get data on any one of these objects, and I can actually specify specific types by looking at the relevant system view. In this case, I'm looking at check constraints, and as you saw earlier, this is showing me, well, I had some joins and stuff like that. I have the name of the constraint, and then I'll have like what object it belongs to here. You just have to put a join on that. And then later on, I get the actual definition of the check constraint. This is where you saw the things like the date of birth and so on. I can get something similar for default constraints, where here's the name of the constraint, the object it belongs to, and this is basically similar to the actual sys.objects view. In this case, they have a couple extra columns. They actually have the definition for the default values. So it's get date for these date columns. It's a 0 here, probably for things like order quantities and so on. Let me do these. I'll put this here. I'll skip foreign keys. This will tell you whether something's a primary key or key constraints. It'll be primary key or unique key constraint, and it should tell you, if I scroll down a little bit here, is there one here? Yeah, it'll tell you if something's unique or primary key, and it'll give you the names of the constraints and again which objects they belong to. And it doesn't give you all of the information that you might want, but you can do joins to other system objects. So I can say, here's the name of the table, here's the name of the primary key, and here's the type of constraint that it is. And I can do similar things here for check constraints. I think this is the one I ran earlier. So yeah, employee birth date, and then here's the definition of the check constraint. So this is something that if you were starting with a new company and you wanted to get some idea as to how many constraints they actually had, you can do these kinds of queries here and get all the relevant information basically in one place. And then you can just copy and paste this data if you had to put it into an Excel sheet or some other kind of documentation. So this one, there's about 4 or 5 more. I'll leave that for an email if someone's interested in getting that information. Let me go back to the slides because I think I'll go into some of the performance benefits, and I think I'll have to skip those last ones here. So I mentioned earlier that back in the day, back in my day, constraints were not often used because either the systems didn't support them or they were too much of a performance hit. They would slow things down too much because you're checking rows as you insert them and so on. And what I want to do is actually show where having constraints can improve. This is not the one I wanted to show. A check constraint can actually improve performance in certain circumstances. Let's do that again. All right, there's already an object. All right, let's select from here. All right, let's insert data. Okay. So I added a check that says this value has to be between 7 and 10. And I inserted some rows there. And when I just do a plain old select, you can see I get data. And then I'll show the query plan here. And what I'm going to do is, if it shows the plan, and hopefully you can see this without me having to zoom it. It's just scanning the whole table, and it's returning 3 rows. And that's just to get all of the data without any where clause. When I select from here with a where condition where A is less than 1, instead of a table scan, I get a constant scan. And a constant scan is basically, I'm not doing any work. I don't need to actually access any data here. And the reason is it's looking at this check constraint, and because this value, the minimum value has to be 7, and I'm asking for something that's less than 1, it knows there's no data there, so it doesn't actually have to scan the table. This is where the optimizer can now use the constraint to determine, hey, I don't actually have to do any work. This constraint is guaranteeing that no such data exists in the system. Now, if I try to use a value that is within range, less than 10, I get all 3 rows because they're all less than 10, and I'm getting a table scan like you would expect. If I get a value that's equal to 10 in the query plan, it's still scanning the table because the constraint allows for that value to exist. But if I try to scan, if I try to select for something greater than 10, I get a constant scan again. This is now outside the logical range. This constraint is enforcing this data to be within this range. So now the optimizer has a hint that can say, I don't have to check for this data. It doesn't, it won't exist in this table. And there's a similar check here. Again, I'll leave it for if people want, I can just email it to them. I'm not going to demo it. We're having if you have a situation where a column, you're looking for a null value in a non-nullable column, the optimizer will know that there's no such value, and it'll also do a constant scan. Let me see here. I'll sum up with some advice I have, and again, this is based on me doing this for too long and pulling my hair out and just trying to save you from turning into me at a later time. Anytime you have a chance, you're going to create a new table or whatever, make sure, have a conversation with your devs. Don't let them do everything as varchar 255. We'll figure it out later. What is this? Is this a number? If it's a number, what would be a valid, what's a valid value? What would be an invalid value? For instance, order quantity. Anything less than 0, a negative number, is not a valid quantity, okay? You might have circumstances where maybe you can order a negative quantity. More like you might have a negative, maybe not a negative price, but you might have to look at, say, discount. You know, discount may have to be a negative number in order for your system to add everything up correctly. That's something that I've encountered as well. Is a discount positive and we always subtract it, or should it just be negative and we just sum everything up like we normally would? The idea is that you're at least looking at the domain and you're determining, hey, like the date of birth in AdventureWorks, these values are out of range, and we should have, say, something to add to it to say that this is not valid. We should also say this data is absolutely required. We don't want to have to deal with missing data in this particular column. When we get into, now that I've got the columns figured out, how do I determine what makes a row unique? What makes this row, how do I know that this is the correct Michael Douglas versus Michael Keaton? Okay. The other thing is, spend a few minutes talking about what happens if we do get dupes. We have two Michael Douglases. One is Beetlejuice, one is Gordon Gekko. How do we distinguish them? You know, how do I make sure that, you know, the Beetlejuice guy is getting his royalties, his residual payments? You know, the Gordon Gekko guy is a Wall Street crook. Let's not give him any more money. Okay, we don't like him anymore. But we do like Michael Keaton. He's Mr. Mom. You know, he's Batman. We want to make sure Batman gets paid. And again, you saw an example of pregnant males. Don't just look at the one column, look at all of the columns and see if there's combinations that you can put checks on to make sure they work. This was a more elaborate example. Unfortunately, I don't have time to go into it, but if I upload the slides, you can look at it. Is if you think about a property, getting a mortgage on a property, you have entities that exist outside of your system. You have a property table. You'll get data from your local government about which properties are available, not just available for sale, but what are properties legal to be sold. You have a lender table. This will be a bank or a mortgage lender of some kind. You have a lendee table. This will just be a person. All of these things, they have their own domains within them. Properties have their own data, their own internal logic. Lenders, again, their own logic. The combination of these three, this is where you have your foreign keys and all that. These end up with, this is what your mortgage table should look like. You have a property that you're going to buy. You have a lender loaning the money. You have a person applying for a mortgage. Those three things have to be linked into your mortgage table. And then the rest of the data for the mortgage table is just ancillary columns from that. So this is, again, for me, this is a good enough, understandable example that you can talk about in 5 or 10 minutes and probably figure out the design 99% to what you'd need and ensure that the data is valid within the table and between the tables. And if you want more on this, for data integrity at least, Deborah Melkin has 3 of these on YouTube. There might be another one, but if you look for her name on, I think it's the Pass Data Community channel on YouTube. It used to be Pass TV. Now it's, I think, Pass Data Community. In addition to Deborah's videos, Andy Yun has a good one on data types. By using the correct data types, you save space and you improve performance. And Angela Henry has an even more involved one on the right data types. All the YouTubes are there. And then there's also a good one from Ed Pollack about database design, basically getting it done up front, you know, solving problems before they start. And this was, I think I got maybe 10 minutes into this and I just copied and pasted this link in here and I'm like, it was really good. It actually explained things a lot better than I probably did here. But I highly recommend all of these. I think if you just search for the titles and the authors, that you'll be able to get, you'll be able to find these on YouTube pretty easily. And I think that's it. Well, there's some examples of what can go wrong when you have bad data. You can probably find all of these. You've probably heard of at least one of these before. And there you go. I'll pay you to use constraints in your systems. Please use them. I love you. And thank you all again.
Perfect. Thanks, Rob, for doing it. It really helps out with constraints. I know everybody has all kinds of questions and has seen more uses for them, and hopefully now they see even more uses for them. So
Okay.
always a good day when that happens.
Were there any last questions? If we have time, I have time.
Let's see. Actually, I think that is it because we actually answered the one question that person had on what kind of permissions is needed to see the constraints, but I think that's it.
Yeah.
You did ask you did show the important part, your email again.
Oh, yes. Yes. So this outlook.com here, email me there. If you'd like slides and scripts, I can send them to you. It'll include all the scripts that I wasn't able to demonstrate today.
Perfect. Well, I believe that does it for all. Thanks again for doing this for us, Rob. And hopefully everyone remembers to join us next time, which will actually be at the end of October. We're actually hosting with Serbi Prakana on Snowflake concepts and architecture for data professionals. So with that, I want to thank you all for joining us today. Hope you've had a great time and learned a lot. So with that, thank you all, and we will see y'all next time.
All right. So long, everyone.